Okay, it seems that we are live now. Welcome, everyone. How are you doing? I hope everyone is having a good day. My name is Victor Munoz. I'm a DevRel at Flare, and today we're going to have a very unique kind of workshop in which we're going to cover Flare data protocols, right? We have been building for quite a while a very unique infrastructure with enshrined oracles. And today I want to explain to you how all of these pieces kind of play together to build other kind of systems. In particular, we're going to discuss also the FAsset system, which, by the way, we currently are on one of these minting stages, right? We just raised the cap to 50 million FXRP that you can mint. But the whole point is that if you're a new developer for Flare today, that is joining Flare today, you will be able to go from understanding what Flare is all about to actually deploy your first smart contract and learn about the different data protocols that we have and do a little bit of other extra steps so that you can start thinking about what can I implement on in terms of solutions that are built on top of these systems. So let me get started by sharing my screen here. It's only going to take 1 second. And in the meantime, I would ask people if you guys can give us a hand by resharing this space. It is very important for us that our educational content, gets visibility. And as you can see here on the screen, we have the developer have documentation. Today, we're going to be diving deep into this as well. It's part of the main materials that we always encourage developers to check. Even if you're an experienced developer, right, you will find all kinds of useful information here, not only like the basic information, like you can see here about how to deploy your first smart contract and use Hardhat or Foundry with Flare, the relevant links and whatnot, but also more advanced things. We have a lot of developer guides that will help you build your first decentralized application, or if you want to run a node and whatnot. So actually, let me move now into my main presentation here. Let me click here, present, full present screen, and let's do this. So, okay, like I mentioned, today we're going to be discussing Flare data protocols. We're going to give a sort of high-level overview. We are already in session 14. If you go to our YouTube channel and type Dev Corner, you will find a dedicated playlist for developers that includes all the different workshops that we have been doing. And we have been doing this for quite a while, so you will find information from very basic things about how this Flare actually works in detail, to deploying contracts, to utilizing our data protocols like the FTSO for price feeds, or the Flare data connector for verifying information from Web2 APIs, which I think is a very interesting case that we're actually going to cover today as well. And okay, let's get started. So what is something that I want you to take into account is that this is a unique opportunity to connect with the Flare team if you have questions. I'm not sure if I'm going to be able to bring those to stage today, but I always check out all of the channels today. We're, of course, not only on X, but also on YouTube. And also, I will be replying to some questions that you guys might be asking on DMs. It's all good. Um, and okay, what is the agenda for today? Of course, we need to set up some goals, right? What we want to achieve. But essentially, we're going to discuss what is Flare, and we're going to have a quick recap about this. And then we're going to do a sort of deep dive into Flare data protocols, what they are, what are the main features, and what you can do with it. I think that keeping it practical for me is something that I really like to, promote. And then FAssets, because this is a clear example of a unique solution that you can build on top of Flare. And we're also going to discuss very briefly something new that we are working on, which is called Flare Smart Accounts. And of course, we will have some time for Q&As, like I mentioned before. There is also a very interesting contest at the end. So make sure you grab your phone and be ready to scan some QR codes. There is some very nice merch that we have to give away for those who participate in this activity. Now, um, okay, like I mentioned before, we want to understand what makes Flare unique. There is a bunch of layer one solutions, right, that are EVM compatible. Flare is one of them. So it's very important that we understand what is really what makes Flare unique, given that there are a bunch of other L1s that are also EVM compatible. And the answer is, of course, our enshrined oracles, which means that we have a way to bring in data that is native and that is secured by the entire network. Now, we're going to learn also how to deploy on Flare and use these oracles in a very simple and straightforward way. We're going to use like a variety of basic tools for this. And we're also going to understand and learn about the basics of the FAsset system and Flare Smart Account, or FSA. And of course, I can discuss, if we have some time, I can discuss some of the next steps. Okay. What is Flare? Of course, like I mentioned before, Flare is layer one blockchain that is EVM compatible, meaning that whatever it is that you build on Ethereum or any other EVM chain, you can easily bring that to Flare and it will work. You will, write the smart contracts on Solidity, like like you probably are used to. But the thing that makes Flare unique is the fact that it is truly unifying data and liquidity. Liquidity is key if you want to build decentralized applications on DeFi, for instance, and data is also key. Like if you think about it, most decentralized application, one way or another, they need to connect with the external world. But blockchains are not designed this way. Blockchains are designed to be secure and and kind of isolated truly. So that means that whenever you want to communicate with the external world, and by external world, I mean either other blockchains or either Web2 sources of data, it's going to be really hard. And the way people have been thinking about this is, let's call an external party that we call an oracle that is going to help us bring this data into the chain. However, when you do this with an external party, of course, there are new risks associated, new levels of centralization or decentralization associated, and new security assumptions. And this is certainly not ideal. You want to build something that is truly reliable and that can communicate with the external world, having oracles that are fully decentralized, fully reliable. And we have seen tons of situations in which, unfortunately, because providers are not utilizing very good oracles, bad things happen. In the case of Flare, our oracles are part of the network. They are enshrined oracles. And what that means in practice is that the security of the entire protocol of the network, it's also the security that will be inherent on the data protocols. So this is very fundamentally different. However, it is kind of hard to see this difference in practice other than when bad things happen, right? Think about the Binance liquidation situation. What was happening there with the oracles, right? That's a good question. So from time to time, we see that there might be some issues that are not properly addressed because we're not thinking right on the oracle problem. However, at Flare, we put a lot of effort into bringing these data protocols to be native to the chain, right? And we're going to discuss two different oracles for Flare. One is called the FTSO, Flare Time Series Oracle, and the other is called FDC, or Flare Data Connector, that essentially will allows you to verify things that happen on other chains and things that also happen in the Web2 world as well. It's quite interesting. And okay, like I mentioned before, we do have these two types of oracles, FTSO, which, if you want to summarize that in one word, in practical terms, why what people use it the most is, of course, for price feeds. So let's assume that you're building any application that would rely on some price data. You would call the FTSO oracle. I'm going to show you like how you do that very easily, and you would get the price from there, right? And it's extremely, I would say, reliable. Okay, let's talk about now the FDC. like I mentioned, sometimes you want to take some actions that happen on chain, in this case on Flare, that are triggered by certain information that are happening on the real world, right? And this is the Web2 world. How you would go about this is you will bring some Web2 data into Flare, you would verify that, and then based on that, some conditions will trigger on a certain smart contract, and some sort of logic would happen, right? And also for things that happen on other chains. What happens if you do a payment on the XRP ledger, for instance, and then you want to verify that on Flare because you want to mint FAssets, right? You want to mint FXRP, which is a representation of XRP on Flare. We're going to talk about that later, but this is essentially the very basic idea. So as the slide there says, by enshrining both the FTSO and FDC directly into our core protocol into the chain, Flare provides every data source with a complete economic security across the entire network. And this is fundamentally different from other infrastructure. But like I mentioned before, this is not like the only thing that matters. What I would say matters the most is what are the types of solutions that I can create if I have this very reliable infrastructure that essentially would allow you to gather information from many places, right? So first we have the Flare time series oracles. The first thing that I want to highlight is that this is for probabilistic data such as prices, weather, etc. Of course, people use the most widely adopted solution is going to be price feed for obvious reasons. If you are doing anything on DeFi, you will need to know what is the value of a certain token with respect to, I don't know, USDC or with respect to Flare, whatever. So you will be relying on this. Um, we do have block latency prices, so these are very fast updates, and we have uh, delta updates implemented with this, meaning that there are incremental updates taking place. And this makes that the whole system is essentially very fast when it comes to updates. But not only that, we also want to create something that is very scalable, right? Because at the end of the day, you will not have one price feed, you will have multiple price feeds, and you will need to have a model that would allow you to have hundreds of different price feeds without congesting anything. And for that, we have certain algorithms that we have implemented. I'm going to share some of these on the Dev Hub once we start checking out the documentation for the details. But essentially, the important point is that we have created a sufficiently, what I would call sufficiently decentralized network with validators that are also price providers in this case, and they're helping validate this information. And so this is a very robust decentralized network that is part of Flare, in which you also have the support for block producing and validating data and all that. And again, if you are thinking about what are the types of price feeds that you can implement, of course, we do have ones already ready for you to utilize. But however, if you want to contribute to the network and you want to help have any sort of custom feed, of course, this is something that is possible with our infrastructure. And there is a dedicated workshop here by one of my colleagues, Anthony, that did an amazing job in teaching how you can implement this and what is the process, how does it look like. Okay, let's talk now about probably my favorite protocol, which is the third data connector. In very simple terms, what this will allow you is to validate external data to Flare's EVM state. Um, and we have here, if you think about what are the kinds of operations and things that I can validate, there is a bunch of things that are specified in our documentation, which I put here on the slide with the specific name, so that if you want to call it on a contract or whatever, you can just call that directly. I'm going to show you how, so don't worry. We have address validity to validate the format of certain addresses on specific chains that are supported. We also can see some of the EVM transaction information that we will call this FDC to verify and retrieve transaction details from EVM compatible chains. Think about Ethereum, of course, Flare, and of course, Sunpay. We have something called JSON API, which now we call Web2 JSON, which is a very interesting tool because it fetches and processes any, in principle, Web2 data using a JQ transformation and then returns an API encoded output. Today, we are actually going to explore this in a very, I would say, straightforward way by running a script, but it's just to show you like the flow. And the flow is something that you can see on the right side of the screen, in which we're going to take, a silly example with the StarWest API, and then we're going to apply some JQ processing rules to extract some data from some characters. Then we will have a proof generation, a cryptographic proof, and then this will trigger also on the flow, we will trigger a contract deployment that will create a list with information about these characters. And, there will be data that once it is verified from this Web2 API that we're going to add so that by the end of the day, you will perform an on-chain calculation to compute a new parameter for this character and add it to the list, right? And that is going to be recorded on the blockchain, of course. And of course, we do have other things that are interesting for payments, confirm and fetch payment transaction details from non-EVM chains. This is something that we're going to discuss a little bit in the next slide, probably about FAssets and how this all works. And we have other information that are relevant for payments. We're going to see this on the documentation within a few minutes. I think that for now we can switch to something that I know that a lot of people ask about how does it work, what are the main components, but of course a lot of the questions come also from the user perspective. They just want to use this product that we're creating via FAssets. And the core idea here is that we want to bring assets from non-smart contract chains such as Bitcoin, Dogecoin, or the XRP ledger to Flare, right? The reason is because we have built this very unique infrastructure, and as you can see, we can now bring the data easily and securely with Flare oracles. So then you can bring part of that liquidity, and then you will have access to programmability. And in particular, of course, people want to do DeFi, right? Because in practical terms, if you're holding assets on these other chains, on the XRP layer, on Bitcoin, what you want to have ideally is to have some sort of yield, or preferably maybe some on-chain yield that is still something in which you have the custody. And with the FAsset system, we have created a solution that allows you to do that. And how this works is essentially you would have your underlying network. Right now, we're talking about the XRP layer because we are in the process of, bringing FXRP, which is this one-on-one representation of XRP, but on Flare, in which you can do DeFi, right? And the flow would be relatively simple. A user, which we call a minter, would select an agent. An agent is just a sort of operator that makes sure to work with the FAsset system to make sure that you get your assets back, to put the collateral and to help you lock your assets and all of that, and pays the fee to reserve this collateral, right? Okay, then the users will send the underlier asset, in this case XRP, to the agent, right? And then how would you verify? Because this happens on the XRP layer. How would you verify that on Flare? Of course, we utilize our Flare data connector, our enshrined oracle, to verify that this actually happens, right? That a user on the XRP layer perform this action and send this to the agent on the XRP layer, right? And then the equivalent FXRP would be minted as a regular ERC20 token on Flare. And then you can do things with it, right? You can do DeFi. You can build multiple applications that go beyond DeFi. Actually, we're going to discuss that because I feel that a lot of people get confused about that. Like, not only you can do DeFi, and from a point of view of a builder, there is an opportunity there. We're going to talk about that later because I think it's very important to highlight. Now, the interesting thing about the FAsset system is not only that it's trustless and an over collateralized system, but because of the way we have built this solution, we can do other things on top and complement with other tools and actually provide a very unique chain abstraction experience, really. And we are implementing this via something that we call Flare Smart Accounts. So in this very first version that I'm going to quickly walk you through today, There will be a workshop focused on Flare smart accounts in the future, but today I'm just going to show you like very basic things. What it will allow you in this version is really an XRP layer controlled account, in which, if you're an XRP layer user, you can perform actions on Flare through instruction on the XRP layer without you having to go to Flare. So the full set of operations and instructions would be abstracted, and a user just would take care of going on the XRP layer and click, I don't know, mint FAssets, deposit into this vault, whatever it is that they want in order to get the yield or the utility for XRP. They can get it directly on their chain, right? And so it will perform a payment, for instance, on the XRP layer address, which will be designed by an operator. So what is an operator? Really think about this in simple terms. It's going to be a wallet, right? For instance, take Saman wallet. You, as a user of Saman, you would just be working directly with them and clicking on something that says, okay, mint FXRP. And then that would trigger the entire flow that we described before for FAssets minting on Flare, right? So it's really nice. And it would be, the system would be, of course, there will be a backend monitoring the incoming transactions and making sure that there is an interaction with Flare. And of course, there are obviously some basic requirements that the payment must transfer sufficient funds, of course, as specified by the operator, and must include, the proper payment receipt and memo fields on the XRP layer, right? What you can see on the table on the left is a table of instructions IDs with corresponding actions, because the way we are rolling out this at this moment is via CLI. So I'm going to show you like super quickly how this works. But essentially, what you would do is you would install a few packages, and you will then provide certain instructions with a certain code ID, and this would trigger certain actions, right? So for instance, instruction ID 01, the action would be a deposit. And what is the description of this action? It would be deposit an amount of FXRP into an upcoming protocol that we have, which is called Firelight, that will be providing staking and vaults. And this, of course, will be designated by what we call it the master account controller contract, that is, of course, is related to the operator, right? And so just like that, there is a bunch of other instructions and operations that you can trigger and you can configure, and think about all the infinite possibilities that you can have because of this, right? There are also some set of custom instructions, as the bottom of the table says. We're going to have a dedicated workshop on that. For now, if you're a developer, I just want you to understand like the high level idea, and just to play around with the CLI. I'm going to show you how within a few minutes. um, Okay, so next the question is, I gave you a quick rundown of Flare, what makes Flare unique, how we utilize our decentralized data oracles. And then the question is what you can build on top. We're giving you a concrete example that unlocks massive value, which is the FAsset system that allows you to bring essentially EVM DeFi for non-smart contract platforms, such as the XRP layer or Bitcoin, right? And it's a very unique type of solution that you can build utilizing these protocols. And today we want to get our hands dirty. This is the only way in which you are going to learn more and more how to build on Flare, how to develop decentralized application, and how to do anything really. You need to get your hands dirty. So today we're going to do that in a very simple way, in which we're going to deploy a contract and utilize the FTSO. Remember, I talked to you about the Flare time series oracles for price fit. We're going to check out a very basic example about how to do this if you're just getting started, right? So if you're new to Web3 development, stay here because we're going to show you exactly how to do that. Now, we're also going to run a full demonstration of this Flare data connector flow so that you can see how it works in terms of verifying information that is from Web2, from Web2 API, this example with the Star Wars characters. We're going to do that, and we're going to walk you through the code. And then we're going to retrieve, just to check out how the FAsset system works, we're going to retrieve some test FXRP contract address, essentially, on custom 2, which is the testnet that we have at Flare. And of course, on the background, I have the link for the Flare documentation, the Flare Developer Hub, which is, of course, always your starting point. Okay, So before going back to these slides and sharing, more information about where to connect with us on Discord, on the Dev Hub, and on X, I think I am going to stop sharing here my screen, and I think I want to bring here some information now about our documentation. Okay, so yeah, we're here on the Flare Developer Hub. And the next thing that we're going to be doing is, of course, if you're new, fully new, make sure you read this, right? Because it's going to teach you how to deploy a smart contract, how to use Hardhat and Foundry. We're going to utilize Hardhat today for one of the examples. And then, it's going to guide you towards integrating Flare's protocols, including FTSO and the FDC, and of course, exploring things with FAssets. There is other toolings and other things that you can explore. Of course, in our chain, you have wallet SDKs, bridges, indexers, and OFTs as well. And of course, you can find information about, our architecture and, how you can contribute to Flare running an RPC node and whatnot. Today, I just want to go here real quick to the FTSO. And remember that I told you some of the features about, for instance, scalability supports up to 1,000 feeds across various asset classes, including equities, commodities, and cryptocurrencies. There is a bunch of data that you can get from here. Also, information about the block latency feeds. We have updates every around 1.8 seconds. So you can actually check if you're like really into the tech side of things. You can check all the information, how it works. If you want to read the white paper, you can click here. We're going to keep it practical, right? So what we are going to do here is just click here on getting started, and it's going to prompt you to a really basic example of a contract that you can implement real quick, and you can open this on Remix. So I'm going to click here for now, and I'm going to see where this takes me, which of course is going to be this IDE for Ethereum. Remember that Flare is EVM compatible, so of course you can utilize this. Remember this warning and make sure that you always utilize like the official link, of course, which is remix.ethereum.org, and it's opening a contract. Now, for those who are not aware, this is like how any modern, I would say, IDE looks now these days. Of course, in the case of Remix, you don't have to install anything, which is why we're going to be using this as a first example. And then when it comes to the code, if you ask, for instance, the AI, it doesn't know what the code does, like just like that. Like it doesn't have the context directly, so you can feed that to it. So I can maybe select everything and put here, explain to me what this code does, and it's going to do it. Oops. Right now, it is not with the lines of code. So what is sharing here is not something useful, right? Because it doesn't have the code. So I'm going to paste it here, and it's going to, give me the information here. Now it's telling me what is the purpose, what are the key components. And I would 100% encourage you, if you're new, that you actually do this and read each piece of this, because it's a good way to get started when you're just building. Of course, if you check out the code itself, it does has a lot of comments, including links, right? And it's telling you what each function is doing, the AI here summary. And of course, as you can see, this is a very basic example in which we're just going to get some price feeds, right? And it's importing some things from the Flare periphery contracts library, which is like the most fundamental piece you will need to learn if you want to build on Flare, like in a more deep way, because it has like all the dependencies and useful information that you can just bring and import. But we're going to talk about how this work with another, environment for development, such as Hardhat or such as Foundry. For now, I just want to go here to the Solidity compiler, and I'm just going to click compile here, and it might take a little bit. And by the way, at the bottom we have our terminal. This is super important. And actually, we do have a button here that explains the contract directly, so you don't need to paste the code here. I did this because I wanted to tell you that it doesn't have the context natively, because then we're going to switch and we're going to do another example with cursor, which it does has more context of the file and the folders and everything. In this case, it's not like that. It's just like an external LLM, and you need to provide the context properly. Okay, so we compiled this. You can just go ahead now and just click here, compile and run the script. We don't want to do that in this example because I want to show you first how you can do this with, MetaMask. MetaMask is the wallet that we are going to be using for development most of the time. So here I am showing you my MetaMask that is on the Flare Custom 2 network, and I have here some tokens that I'm going to be using for testing purposes, right? So the first thing that you do each time that you want to build, you grab your test tokens, right? So what I'm going to do here is I'm going to click here on environment, and instead of keeping it with Remix VM Prague, the Prague version, I'm going to put here browser extension, and I'm going to select here injected provider MetaMask. Okay, so now as you can see, my account that finishes in EC is now connected here. And just to make sure, you can double check that information here with the information of your account here on the top. Okay, this should run just as it is because it's an example. We'll see how it goes. And I'm just gonna here, I'm just gonna click deploy directly. And you can see here on my terminal, it's trying to execute something. And now my wallet is prompting me to deploy this contract. And this is a request from Remix. Of course, this is the part in which you want to make sure you have the right link. You're not transacting with a malicious site, and it's requesting a network fee, which is ridiculously. It is so low that it is just super low fee, right? I'm gonna click here confirm. So what's happening now? What's happening? Well, it is deploying the contract. I'm seeing here some messages on my terminal already, right? It's not a big deal here about this issue with the verification. It's all good. It's going to be verified in any case here, and you can check it here on testnet root scan, and it's giving you the address. And you can see the information about the deployment on the Explorer, of course. Now, the Explorer here, make sure you also always double check the links. We're on custom 2 slash, m-explorer.network.flare.network. And what we can see here is, of course, the transaction hash, the block confirmations, the timestamp. Of course, the most important thing I think for this is check who is deploying this. And this is me, right? This is my wallet address. And this is because I connected here on Remix. Okay, so cool. We have deployed our first smart contract. Then the question is, what can I do with it? Of course, you can interact with your contract, right? So if you expand here where it says deployed contract at the bottom of Remix, you will see here you can interact with it. What each of these function does, it is explained here by this LLM essentially, but we're just going to query some prices. That's what we're going to do here today. So we're going to call this function get FTSO v2 current feed values. What is this function? We can see it here. Pretty straightforward. It's going to give you get FTSO v2 current values. It's this function here, and it's going to essentially give us 3 different examples that are here for the values of Flare versus USDC, Bitcoin versus USDC, and Ethereum versus USDC. So, okay, I can just click here and call this function, and you will see the information of the call on your terminal in terms of what is the input, what is the output here, and the decoded output, and information about like details of the decoded output. You can see the values of the feed here, but also you can see it here, right, on the left side on the corner. And if you check this out, you will see that this seems to be first the price of Flare, then the price of Bitcoin, and then the price of Ethereum in terms of USDC. But of course, you need to add the decimals for this to make sense. So you need to, for Flare, divide by 7. For, move the comma essentially 7 places. For Bitcoin, move it 2. So if you move it 2 here, you will see it's $808,000 roughly, and a little bit more. And if we go, for instance, to coin market cap, and we click here on the data, we will see the specific value 108,000 and whatever Well, it just moved, right? But it's essentially that. And that's the information. We can see that Ethereum at this moment is about $3,848, right? And you can double check that with the information on other sources. But that is essentially it. Now, just to recap here real quick, what we did is we just went to the Flirt Hub, we click it here on FTSO, we click on get started, and we just open up here things on Remix, which gave us this nice environment in which we can, just deploy our first contract without having to do anything. And we actually did that with our own wallet. So what I would suggest to you, if you're just getting started, is that, of course, start with your MetaMask wallet. That should be only for development purposes. You never want to mix your development environment with like where you're going to keep your real funds for you as a user, your money. That's a separate thing, right? That's a separate thing. And then, of course, the first thing that you will need in order to deploy a contract on Flare is request test tokens, and you can click here, and you will be getting access to the official faucet. Now, here you want to put the information of your wallet, right? And it's fairly straightforward. I'm going to put here my wallet. Probably it's going to say no because I requested already. So I'm going to click here request, and it says you have received funds too recently, right? For this, I cannot, but I can also request, for instance, USDT zero to play with stable coins, or you can request FXRP. Remember that I told you you can play with this nice idea of bringing new utilities for FXRP that goes beyond DeFi. Well, you probably need some test tokens, so we added that for you there. Um, okay, guys, I think that we completed the first exercise of deploying our first smart contract and testing this on custom and getting our first price feed utilizing the Flare Time Series Oracle. Now, what I want to do next is a little bit different. Let me share this over here. What I have, what I'm showing you here, it's a rather more complicated piece of code that is on a different environment. I'm utilizing here Cursor, and what I'm using here is a hardhat started repo from the Flare Foundation. So let me go back real quick here and explain to you what we are going to do. If you explore our documentation, at some point you will say, okay, I want to have one sort of a starter kit in which I have all the information I can think of for having all the dependencies, relevant contract address, everything to interact with Flare in the most straightforward and seamless way, right? If you want that, we have created for separately for hard hat users and for Foundry users, which are the most popular frameworks to build in crypto, right? In Web3 development. And so essentially what we would ask you to do is just clone this Flare hard hat started. Let me click here real quick. We have here the main repo from Flare Foundation, and it's providing you all the information about how to clone it, then switch into this folder, and then just installing jar or npm style force. And then, of course, you have to set up your M5. We're going to discuss that very briefly, right? And adding your private keys, we're going to discuss that as well for security measures, how it works. And then you can just start writing testing some contracts that are already there. And what I did here is I just opened all of this on Cursor, which is another IDE. It's not the same as Remix, but what I like about Cursor is that I have access to an AI helper that is actually kind of an agent, so it can modify your code. It has more information about the context, so it can really understand and teach you things and modify things. Of course, you have to be super careful about what you want to do with it. And for this example, what we're going to do is actually to explore the FDC or Flare Data Connector with the specific flow of bringing Web2 data into Web3, verifying it, and perform certain action on chain. So if you are still kind of lost with this, let me just quickly summarize this part for you. You want to grab the hard hat or Foundry starter kit, clone it, and get your development environment up and ready. I already did that. I don't want to spend time on that, so I already did that on Cursor. The reason, because just going to interact with the AI there. Now, what I'm going to show you now is what exactly is that we're going to be exploring. We're going to be exploring a full flow with a script that is going to trigger the FDC verifiable. Like we're going to verify Web2 data utilizing the FDC. That's what we're going to do. And of course, we do have like the full explanation of how this works and how you can, retrieve data from the data availability layer and the different types of attestation that I mentioned before for address validity, and more importantly for us, for Web2 JSON or JSON API, right, to fetch and process any Web2 data using JQ instructions and filters, and then return it an API encoded output. Okay, and this is what we're going to do. And actually, if you want to play alongside this, you can just go to the FTC guides for developers, click here on hard hat, and then you will have different examples. The one that we are going to be showing today is this Web2 JSON. So now you can see here, it is telling you, all the steps, all the code snippets with the relevant pieces of code, how it works to prepare an attestation request, what are the required fields, what is the reference documentation that you will need to read in order to be able to not only reproduce this, but modify this, because what you want to do as a developer is first go to this developer environment, set up everything, run the examples, and then you want to utilize this structure, this folder, to do your own thing, create your own decentralized application, add your own back end, add your own flow, add your own front end, and having everything there already set up easily with any Flare dependencies, right? So it's giving you some example values here. We're not going to dive deep into this. It's not necessary at this stage, and it takes quite some time, to be honest, to grasp it the first time. And it's also giving you instructions about the encoding functions, right? So what I want you to take from this really is what we're going to do as an example is something that is here to request information from an API that is from Star Wars. We're going to validate that information and then create a list with enhanced information about these Star Wars characters. And everything is going to be running from this environment that I set up on Cursor with the hard hat started. So actually, let's explore the code. So if you start, if you install the hard hat template here, this is the same structure that you will see, right? You will have a folder with artifacts, another one with contracts, very important, another one with the scripts, the different utilities, and of course your emp example, which you want to make sure you put here your own private keys, not this one. These are a private, like this is a public thing, and you don't want to do that, of course. But however, if you want to run it with that, it's going to work because we set that as an example. Now, here, what you can see here on the bottom, just like with Remix IDE, is the output of the terminal. Why? Because I already run the code just because I was testing it, and it started giving me the full information about what is the type of attestation, what is the request body, meaning the information, and where are we getting this information. So we actually can click here on the link, and it's going to open up the information from the place in which we want to retrieve this data, which again is like the swapping information here. Let's see if I can make it work like this. And we can see the website, and you can query with this information. You can type here films, and it's going to give you a lot of information about the whole Star Wars saga. I don't want to go into the details of this. It's not really relevant. I want to understand how we can utilize the FTC and how the flow works, right? So let me see if I can open up here a new terminal. And here, what I want to run is this example, right? Which is called web2json.ts. It's here on the scripts, web2json.ts. And here is the code. And is essentially providing you what is the line of code that you need to put in order to run this flow that is going to verify this data. And then, it has a bunch of instructions and it has a bunch of functions. We're going to see how we can interact with it, utilizing Cursor with the AI agent so that it can explain to me what is doing the code, like and what each piece of the code means, and how can I modify it for my own example. You might want to do other things, right? That's the whole point. So you're going to type here yarn hard hat run scripts FTC example web2json.ts. You want to do this on custom 2, which is a test environment, and you just type here enter, and it's going to essentially, the output that I'm expecting is the same, kind of the same output that I'm seeing here when I run it before. So it's going to give me the ABI signature, the information about what I want to process using the JQ filter in terms of information of these Star Wars characters, right? The name, the height, the mass, the number of films, whatever it is that I want to play with. And then, of course, it's going to show me the ABI encoded request. It's going to tell me what is the information about the voting round, because when you ask FDC, please verify this information, the Oracle, what it will do is you will have a bunch of other, all the data providers and people that are validating things on the Flare network, on this decentralized network, and they will actually perform the same exercise as you. So they will go and query the data with the information that you pass, and then they will see if they get the same result. If they all agree, then it's all good, and this test will pass, and then you will have this information available to do whatever it is that you want to do on chain, right? In this case, there was some error here, but then it requested again, and then everything is okay. And then it's requesting for the data availability layer to generate the proof of the fact that the verifiers got the same result as you, essentially, right? And you will get here some awful things, this response hex. You don't need to worry about this thing. The only thing that you need to worry about in this part is that you're actually getting a Merkle tree with the proofs, right? And then it says here, successfully submitted source code for contract. Now it's deploying a contract, a smart contract. What it's going to do is going to take the information from the characters, and it's going to perform, let me scroll down here to the end, is going to perform a new calculation on chain, which is called BMI, body to mass ratio index, sorry. So what this does essentially is that it takes certain parameters. I think it's the ratio between the height and the mass, and it's going to compute that on chain with this smart contract, and then it's going to add that, append that to a list with the information of the character. So you started with certain information of a character from Star Wars, from the Web2 side, you query the data, then you verify that data utilizing the FTC, and then at the end, you perform this calculation of this new parameter, the BMI, and you add that to a list. So now you have an enhanced list on chain with a new parameter for each character. And all of this is thanks to this flow that I'm showing here. And I'm going to see if the AI here is able to catch up everything. And I'm gonna put here Control A just to see. Let me see if I can just copy all of this awful thing here, and I'm gonna ask the AI directly to explain me the flow, right? I'm gonna say here, what is this flow about, and show me the code, the relevant code. Show me the relevant code for each step, because you need to understand the flow in order to modify this. You might want to modify this for, for your own decentralized application in which you bring data, for instance, from social media. You want to bring data from Twitter into Flare network to create your own reputation system, on-chain reputation that mixes things from social media and things that are happening on-chain, transactions and whatnot. Well, you would utilize the FDC to verify this information, and then you would utilize this exact same flow that I'm showing here with this example of this Web2JSON example for Star Wars, but now you would modify that for your own case, which would be, like I mentioned in this example, for Twitter verification, right? So as you can see here, the AI agent is quite smart and able to actually map each piece of the output from the terminal, from the code that I just run, into a piece of code, and it's telling me where this is, right? It's telling me, for instance, step-by-step flow with relevant code. Step one, you're preparing an attestation request that you're going to then submit to the FDC server. We do have a server that helps you translate things, and that's a different story, but here it's telling you what is the piece of code that does that, right? And it's telling you you have this async function, prepare attestation request, and you will have to provide the URL, what is the headers, and what are the query parameters, very important, and what is the ABI signature, right? You need to provide this information because then you will want to do something on chain, but you will need to tell the contract, how to encode and how you are going to encode and decode this, and what the contracts needs to grab in terms of information to perform the on-chain calculation in this example. And then it's showing me what is the output of this, which is something that we can verify here on the terminal, which is like the URL, then the prepared attestation information with this log, the attestation type, which is a Web2 JSON example, what is the source ID, where are we getting this information from, and what is the ABI signature, what are the different components, and the structure, right? We have this, first we have a string, then we have a name, then we have, different types of data structures inside this ABI signature. And then, it will continue. It will teach you how you can submit the attestation request to Flare, how you're interacting with this main contract, which is the Flare FTC Hub contract, and whatnot, right? Again, I want you to run this and figure it out on your own because it's going to take a little bit of time. I'm just here to show you what is the main example, what it does, how it works, so that you can then play with it. And I think because of time, I think to get moving now, let me see here, where is my next example that I wanted to show you. What else I promised you? Let me move backward here. Retrieve test information for FXRP. Yeah, so I have opened up here another different environment here to teach you about this. What you're seeing now on the screen is the same kind of hard hat starter, but now I'm utilizing a different environment with Visual Studio Code. I know that most people actually use this, and I actually use it as well. I sometimes use Cursor when I just want to vibe code things, but in general, I would probably use uh, VSS. And here, what I'm doing is just running another example. So I'm going to the documentation. I'm going to show you this now. And I'm just running another example, just like I did before for the FDC. So we started here with the FDSO, then we moved to the FDC, and finally, we're coming here and exploring the FAsset system. Here's all the information, by the way, about how the minting, the redemption process work, who are the key participants of the system, and specifically what the agent does, how the collateral providers work, what is the flow, blah, blah, blah. For you, today, we just want to go to the developers guides on this section and try to retrieve something. You can, for instance, get the asset manager address or get the FXRP token address, right? And if you click here, it's telling you, okay, the prerequisites is that you install the Flare Hard Hat Starter Kit, which we already did. And you have to call the periphery contracts. We have it already on a template, and then just basic understanding of the FAsset system, which I hope that you now have. And you have the script here and the code example and what to expect. Now, I prepared this, like I mentioned before, beforehand. And yeah, so we have this example here that, let me see what I run here. Oh yeah, if you install this and you can then run the lines of code of the documentation, then you will get the FXRP address and you can double check this information with the documentation, right? One thing that I think is very interesting though, that is also part of this this hard hat starter that was created by another DevRel of Flare is tracking the minting cap, right? Because right now what is happening is that Flare is each week is incrementing the cap for minting FXRP, and you can track this with a simple script that we have prepared. And actually, I'm going to see if I can run it live. I've been doing this because I want to see what is the minting cap in terms of the capacity and the minting cap usage that we have. So this is information that you can get, very valuable information that you can get about the FAsset system as we run this on testnet and then now on mainnet, right? And you can get this information. A lot of people have been asking about it, and Kristaps provided this. So the only thing that you need to do is just go to the hard hat started, fork that, and then go and run this script, mintingcap.ts, that is on the FAssets folder, inside the script folder, and you will see this information. Don't worry about this tenderly warning. You can completely ignore it, and you can see the progression here. We have available lots to mint. We have quite a few yet. We're at 72% capacity. And this is information that anybody can query and verify on chain. Now, guys, I think that I'm up to the time now. I think we're ready to finish, but I just wanted to quickly show you what we are working on with the Flare Smart account. So I'm clicking here on the DevHub Flare Smart accounts. Like I mentioned, on this first iteration, what we are doing essentially is just having a basic workflow in which you control XRP ledger accounts and then perform actions on Flare. And the important piece of information for you is learning about interacting with this table of instruction IDs for certain actions: deposit, withdraw, approve, redeem, reserve collateral, claim, and claim, withdraw. And if you want to add custom instructions, you can do that. So if you scroll down here and go to the developer guides, you can find these Flare Smart Accounts CLI. And essentially, it's kind of the same flow, right? You would clone a repository from Flare Foundation specifically for these smart accounts. You will then install all of the requirements. This is utilizing Python. Of course, set up your env and .env file. This is private, right? And then you can play around, and it's telling you some instructions and what to expect. You can do this easily, and we're going to have a dedicated workshop for this. But right now, I think we are kind of on time, and I think I'm in the position now to share this QR code, right? Let me expand on this and join the fun. So what is this? Again, I have just explained to you in simple terms, I hope, how Flare works, what is unique about Flare, how does the FTSO work, how does the FTC work, how does the FAsset system work, how to run part of this code. And if you scan this QR code, there will be a set of questions, very basic ones. If you watch this, tutorial, if this workshop is something that you can play the recording after, you will be able to answer this fairly simple, right? And if you answer this, you have a chance, and the answers are correct, you have a good chance to get some merch. We have a nice set of merch that we're giving away for free. And of course, this is something that, is a unique opportunity in that sense. And just participate on this. And again, I think I'm going to share now. Of course, there is time for Q&A. I'm not sure. But of course, if you want to join Flare after this workshop, if you want to explore more, you can go to the Discord and ask questions there. You can follow us on X, of course, to all the latest updates. Usually they go there first, right? And also we're on LinkedIn and YouTube and everywhere. But it's good to be on X to get the latest new and try to feel the pulse of the community. And of course, the DevHub, which is the documentation that we utilize it to get all the information about these different examples of how to deal with the FTSO, FTC, and the FAsset system. Okay, guys, I think we're over the hour now. If you have any questions, you can always DM me and whatnot. And I think with this, we can close this space for today, this live stream.